Algebra 2, section 8.3, it's called population parameters, and it's on page 545. The word parameter comes from like an enclosement of what we're talking about. We're going to talk, and I'm going to read a couple things to you, but the first thing that we're going to talk about is the population mean. What does the word mean mean?
Average.
This is right. This is the average. Okay, so a population mean is the average values of all the given data. Okay, of the entire population, and it's represented by this thing here. I think this is called mu. It's like a cursive U. Okay, it's a cursive U. Okay, so that's population mean. We're also going to discuss this. It's called population proportion. Okay, and it's represented, it is another parameter, which is number of members in the population sharing a particular attribute divided by the number of members in the population. So this is actually a fraction. It's the letter P equals, it's what we wanted, it's over the total population, but this would be what we call maybe a favorable. Do you remember that we use probability? So whatever we're looking for over the total is our population proportion. Okay, let's take an example. The example's on page 545. We have 5 students that are taking a test or a quiz, and here are the scores: 100, 100, 91, 84, and 75. Now we use a small data to show how to do these, but we'll get the larger data. Okay, so the average of the population, they write it like this, and I like this value, but this symbol right here is called summation. What it means is you add up all the x's, all the test scores. This is called summation, this symbol right here, and then we divide by the total. So what we're going to do is we're going to take 100 plus 100 plus 91 plus 84 plus 75. So on your calculator you can add those up, and then we're going to divide by 5, right? Because there's 5 of them. Okay.
90.
So you get 450 over 5, correct? Which is 90. So the average of that population is 90. We've been doing that for a long time, correct?
Yes.
Now, the next question says we want the fraction or percentage of tests that are higher than 90. Okay? So let's take a look at the tests that are higher than 90. We're looking for a population proportion here. This number, and this number are higher than 90, correct? So that is 3 out of the total 5, which is 0.6. That is as a decimal. Now sometimes they'll ask you to do that as a percentage, Harper, and you'll have to change that to 60%. You understand that? Yeah. Okay. So let's take a look at example 1. This is example 1 on page 545. It's your book. It says all 51 students, take a look at that chart there, receive surveys to see how many classes they are taking this semester. The results are shown in the chart. So there's 51 students, correct? We want to know the population mean, okay? How many classes have 6 residents? 1. So to find that total, we're going to take 1 times 6. Do you understand that? There's 1 class, 6 kids. All right, now you have 2 classes that have how many residents? 5. So you have to take 2 times 5 to find that total. Now we're adding these up as we go, and then 3 have how many? 26.
Oh.
And then 4 have how many? So this is how we're coming up with the 51, right? And then 5, or this is plus 5 times 3, right? So we have this one, this one, this one, this one, and this one. So if we look at it, we have 6 plus 10 plus, what's 3 times 26?
Or 70.
70? 70 what?
78.
78, thank you. Plus 44 plus 15. Would you add those up for me, please? There's how many?
153.
153, so that's our total, right? 153. So to find the average, what do we divide by?
51.
51. We divide by 51, because it told us that all 51 were surveyed to see how many classes they were taking. This is the number of residents they've taken. Okay, so what is that value?
3.
3. So your average is 3. So sometimes you gotta be careful about what you're doing, all right? So let's take a look at the guided practice. Well, let's take a look at example 2 on page 546. Says, in a population of 250 people, whoops. '90 said they prefer running over hiking. 90 said they prefer running over hiking. Okay? Alright, the first question says, what is the population portion of people who prefer running over hiking? Okay, so what is the population proportion? P. It is 90 over 250.
So do you want that in percentile?
No, they want that as a decimal. So what is it as a decimal? 0.36. The next question, Bo, I think is going to answer says, what percent then prefer this?
36%.
It would be 36%. You see that? Bo?
Yep.
All right. So you see how to do both of those, the mean and the population proportion, correct? All right, so let's take a look at the margin of error, which we're on page 546. It says a survey of a random sample is a valuable tool for generalizing information about a larger population. The accuracy of a sample survey is based on 2 key factors, the margin of error, which is highlighted, and the confidence level. The margin of error tells you that the interval in which the result will fall relative to the real population value. The statisticians have found that for large populations, the margin of error for a random sample of size n can be approximated by this formula. Okay, now you don't have to know this formula because you're going to get to use your notes, but you better have this formula in your notes in case I don't allow the book. But the margin of error is this. This is a formula. The margin of error is plus or minus the square root, 1 over the square root of n, where n is the number of people, times 100. Okay, it's on the next page, on page 547 at the top of the page. Okay, now, this is actually used nationwide. And you hear, if you listen to the news, they'll say this percent with the margin of error of this. Okay, and that kind of tells you the amount of size. But you got to have a certain size that matches your margin of error. Okay, let's take a look at example 3. It says a survey is conducted to determine how many people will vote for the school presidential candidacy. The result of the 500 students, so that is N, surveyed showed that 62% of the vote will vote for candidate B. Find the margin of error. Guys, the 62% has nothing to do with finding the margin of error, but it's used at the end to find what your percent is between. So to find the error, we're going to see our margin of error is 1 over the square root of 500, and this is plus or minus, times 100. Okay? So if you would take your calculators, and you would take 1 divided by the square root of 500, and then multiply that by 100, to the nearest tenth, tell me what you get.
4.8. Wait to the nearest 10th.
Yep,
4.5.
4.5%. Okay, this is a percent. Okay, Harper, did you get it?
Yeah, never mind.
Okay, so what this means is that's the margin of error. Guys, this is the margin of error. The second question says, what is the range, the real proportion range, okay? So what we do is we take the 60, remember the 62%? We take 62% and we subtract 4.5%, get that answer, and then we take 62% and we add 4.5 because it's both minus and plus, and that will give us our range.
Where'd you get 62 from?
It was in the problem. It said, showed that 62% will vote for candidate B.
Okay.
You see that? Okay, so what is the first one? 57.5% to what?
66.5.
Okay, so you could be off 66.5. You can be off that much is basically what it's saying. Okay, that's how much it can range from. All right, let's take, do we need to do another one of those? What's that? You sure? Okay. Now, what would happen if I gave you the margin of error and you were to find how big the sample size was? So in other words, reverse it.
Wouldn't you just take it, times 1 over square root of 500? Or square root of the n?
Yeah, I think you're following, yeah, I think you're saying it right. Let's take a look and take an example, shall we? This is example 4, okay? It says you're a member of a research team that you're going to run a simulation. The simulation needs to result in an adequate sample size and the margin of error for each trial. Find the sample size for a plus or minus 3%. Okay, now that is the sample size. In other words, this plus or minus 3, guys, that equals that formula. Plus or minus 1 over the square root of n times 100, correct? Okay, so what happens is we're going to multiply by, first of all, 3%, that probably needs to be changed to 0.03. Let's try that again. Okay, we can drop the plus or minus because they both have plus or minus on both sides. And so I'm going to take, n is in the denominator, right? So I'm going to take 0.0 square root of 3 times the square root of n, and that equals 100, correct? So to find the square root of n, we're going to take 100 divided by 0.03. Would you take 100 divided by 0.03? What do you get? 3,000?
Yep.
333.3 with a line above it. That's what it looks like. 3,333.3
Oh,
with the line above it.
Just a bunch of 3s.
okay. I said that wrong then, didn't I?
We divide by 100.
Oh, sure. If I divide by 100, I'm sorry. When I divide both sides by 100, that's how I got the 0.03, correct? My bad. So this should be 1. So 1 divided by 0.3. Try that. There we go.
33.3.
There we go. 333. It keeps going, right?
Yeah.
Now, square both sides. What do you get for n? Because it's a square root of n. You want n.
1,108.89.
1,000. They got 1111.
That's what I got.
Okay. Okay.
0.111.
So this is about 1,111 sample size. Okay? Okay, let's do another one of those since I kind of blew that one. Let's try another one of those, okay? Let's try this one, plus or minus 10%, okay? I'll do a better job maybe this time. So we have, if I have 10 equals 1 over the square root of n times 100, correct? I'm going to divide both sides by 100. So this is 100, and this is 100. Let me show this a little better. This cancels with this, and so I get 0.1 equals 1 over the square root of n I take both sides times the square root of n, so I have 0.1 times the square root of n equals 1. What is 1 divided by 0.1?
10.
So I get the square root of n is 10. So n equals
100.
100. So that's a 100 sample size. You get that? So you have to have a sample size of 100 in order to have a margin of error of plus or minus 10%. You have to have at least 1,111 people to have a margin of error of plus or minus 3%. Okay? Alright, so let's take a look at the exercises, shall we? We're on page 548. We're going to end up doing numbers 5 through 19. Okay? The first one is manufacturing, clothing manufacturer. You're going to take those, right, and add them up, correct?
Mhm.
And you're going to find the mean. Harper, you understand that?
Mhm.
6, 7, 8, and 9, we're going to find the following population proportions. So you're just going to take each one of those numbers divided by what, in this case?
500.
500. 10 through 15, you're going to find the margin of error using that formula. And then 16 through 19, you're going to reverse that formula just like we did, right? Okay? All right, this is due tomorrow. We can. Okay? Well, is anybody gone tomorrow? Okay. So this is due tomorrow.
I
All right.
might be, I don't know.